Welcome back to Click Future, where your future is a click away. This is the second episode in our Quantum Horizons series, where we explore the fascinating intersections of AI, quantum computing, and space achievements. Artificial intelligence has already transformed our world. Quantum computing promises to do the same. But what happens when these two revolutionary technologies converge? Today, we're exploring AI's quantum leap, how the marriage of quantum computing and artificial intelligence could solve problems we once thought impossible. From discovering new materials and medicines to understanding climate change at unprecedented levels of detail, quantum AI represents a paradigm shift in computing power. And it's happening faster than you might think. As Einstein once said, the distinction between past, present, and future is only a stubbornly persistent illusion. Today, we'll see how quantum AI is collapsing the time frame between scientific discovery and real-world application. To understand why quantum computing is so revolutionary for AI, we first need to recognize the limitations of today's AI systems. Modern AI, particularly deep learning, has made remarkable progress by scaling up. More data, bigger models, more computing power. GPT-4, for instance, reportedly has over 1.7 trillion parameters, but this approach is hitting physical and computational limits. Training these massive models requires enormous energy. A single large language model training run can generate as much carbon as 5 cars over their entire lifetimes, and despite their impressive capabilities, these systems still struggle with certain types of problems. Consider optimization problems like the traveling salesman problem, finding the shortest route between multiple cities. As the number of cities increases, the possible routes grow exponentially, quickly overwhelming classical computers. Or simulating quantum systems like complex molecules for drug discovery. Classical computers must make significant approximations, limiting their accuracy. As Richard Feynman famously observed, nature isn't classical, damn it, and if you want to make a simulation of nature, you'd better make it quantum mechanical. This insight is at the heart of quantum AI's promise. Quantum computing offers several key advantages for AI applications through specialized algorithms that exploit quantum properties. Take Grover's algorithm, which can search unsorted databases quadratically faster than classical algorithms. For AI systems that need to search vast datasets, this could mean finding patterns and anomalies much more efficiently. Or the HHL algorithm, which can solve certain linear systems of equations exponentially faster than classical methods. Since many machine learning problems involve linear algebra, this could dramatically accelerate AI training and inference. Researchers are also developing quantum neural networks, AI architectures that leverage quantum properties like superposition and entanglement. These networks can represent much more complex patterns with fewer nodes than classical neural networks. In 2024, researchers at Google demonstrated a quantum machine learning algorithm that could recognize patterns in data that were completely invisible to classical AI systems. The quantum advantage wasn't just incremental, it was transformative. Quantum machine learning isn't just about doing the same things faster, it's about enabling entirely new approaches to AI that aren't possible with classical computing. So what can quantum AI actually do today? And what applications are on the horizon? In pharmaceutical research, quantum AI is already accelerating drug discovery. By more accurately simulating how molecules interact, researchers can identify promising drug candidates much faster than with classical methods. Pfizer used quantum machine learning to screen potential COVID-19 treatments, analyzing molecular properties that would be computationally prohibitive with classical AI alone. In finance, quantum AI algorithms are being developed for portfolio optimization and risk assessment. JP Morgan Chase has been pioneering quantum algorithms that could better predict market volatility and optimize trading strategies. For climate science, quantum AI could revolutionize our ability to model complex systems. Classical climate models must make significant simplifications, but quantum AI could simulate Earth's climate with unprecedented detail, potentially giving us more accurate predictions about climate change impacts. Perhaps most exciting is the field of materials discovery. Quantum AI can efficiently explore the vast space of possible materials to identify those with desired properties, like better batteries, more efficient solar cells, or superconductors that work at higher temperatures. What once took decades of laboratory trial and error can now be simulated in days or hours with quantum AI. We're accelerating the materials discovery timeline by orders of magnitude. The field of quantum machine learning is advancing rapidly, with several key breakthroughs in just the past year. One major challenge has been training quantum neural networks efficiently. In late 2024, researchers at MIT developed a new training method that converges exponentially faster than previous approaches, making quantum neural networks practical for more applications. Quantum reinforcement learning, where AI learns through trial and error, has shown particular promise. A quantum reinforcement learning algorithm recently outperformed classical algorithms in optimizing complex manufacturing processes, reducing energy consumption by 28%. Quantum generative models, similar to the GANs that create deepfakes or the diffusion models behind image generators like DALL-E, can represent much more complex distributions than their classical counterparts. This could lead to more realistic simulations and synthetic data generation. Einstein's work on relativity revolutionized our understanding of physics. Similarly, quantum AI is fundamentally changing our approach to computation and problem solving. Most current implementations use hybrid approaches, quantum processors handling specific tasks where they excel, working alongside classical systems. This pragmatic approach is yielding results today, even as fully quantum systems continue to develop. As with any powerful technology, quantum AI raises important ethical questions. Perhaps the most pressing is access. Will quantum AI create an even wider technological divide? Quantum computing hardware remains extremely expensive and specialized. The companies and countries that control this technology will have significant advantages in AI capabilities. Cloud-based quantum computing services are one approach to democratizing access. IBM, Amazon, and Microsoft all offer quantum computing resources through their cloud platforms, making the technology more accessible to researchers and businesses worldwide. Open source initiatives like Penny Lane and Qiskit are also helping to democratize quantum AI development, providing tools and educational resources to a broader community. We need to ensure that quantum AI benefits humanity broadly, not just those with the resources to access it. This requires intentional policy and investment in accessible quantum computing infrastructure. There are also questions about AI safety and control. If quantum AI can solve problems beyond human comprehension, how do we ensure it remains aligned with human values and goals? This is an active area of research in the quantum AI safety community. The convergence of quantum computing and artificial intelligence represents one of the most promising technological frontiers of our time. While still in its early stages, quantum AI is already demonstrating capabilities that were theoretical just a few years ago. In the coming decade, we can expect quantum AI to transform fields from drug discovery and materials science to finance and climate modeling. The computational problems that have long resisted classical approaches may finally yield to quantum methods. As Einstein grappled with the strange implications of quantum mechanics, he reminded us that we cannot solve our problems with the same thinking we used when we created them. Quantum AI embodies this principle, offering fundamentally new approaches to computation and problem solving. If you found this exploration of quantum AI fascinating, please hit that subscribe button to join us on this journey through the technological frontiers shaping our future. And leave a comment below. What problem would you most like to see quantum AI solve? In our next episode, we'll explore how AI is revolutionizing space exploration in space-time algorithms. This has been Click Future, where your future is a click away.